Hi everyone, today we're going to talk about Scatterplots and Lines of best fit. So during this video you should pause it wherever you need to, rewind what you need to rewind. We're just going to review how to make a scatterplot, and something new would probably be drawing a line of best fit. You may have done it last year, but I don't think it's that everybody has. So we're going to learn how to draw lines of best fit today. The table gives us data. So the table shows data for the amount of fuel used by a hybrid car at different speeds. So we've got speed is in kilometers per hour, anywhere from 40 up to 110 kilometers per hour. And we've got fuel consumption. Fuel consumption in Canada is measured as how many liters you use for every 100 kilometers you drive. So liters per 100 kilometers driven. In the United States, it would be miles per gallon, so a little bit different of a measurement. The higher the liters per 100 kilometers, the higher this value, the more gas you're burning to go 100 kilometers. So that's not as fuel efficient as a lower number like 3.1. So the first thing we're going to look for is any patterns in the data. So I think what you should see is as the speed increases, so as the speed increases in the table, the fuel consumption stays the same for a while, but once it gets past a certain speed, it starts going up quite a bit. So I think that's what we should put as the speed increases, the fuel consumption. It doesn't always get hit up every time because it's the same at the beginning. So I'm going to put the fuel consumption tends to increase. It doesn't always increase. For independent and dependent variable, this one's kind of tough to decide. Does the fuel consumption depend on the speed, or does the speed depend on the fuel consumption? And actually, fuel consumption depends on speed. The other hint that they give you is the first one's always x, and x is always independent. So this is x, that's y. It's always in order. So the independent variable here would be speed, and the dependent variable would be fuel consumption. Hopefully I'm not going too fast. So what we're going to do is, and just as a reminder, this is always x, and this is always y. Independent's always x, dependent's always y. And what we're going to do next is draw a scatter plot for the data in the chart below. So we have to make sure we choose a reasonable scale, and we have to make sure we go up by the same amount each time. So when we started making graphs, there were a few people who were skipping things right near the origin, so we have to be careful with that. And we're going to fully label the graph. So I'm not going to waste your time with this. You can pause it right now and make yourself a beautiful beautiful graph. And I'm going to switch over to one that I've already done because you don't need to see me make a graph. So here's my graph, but I'm missing one thing on my graph. So see if you can figure out what I'm missing. Hopefully you figured out that I'm missing the title. So my title should be speed versus fuel consumption. Underline it. So there's my graph. Fully labeled. I've got all the points, so you can double check. When you're making a scatter plot, sometimes it's hard to tell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So what we're going to do now is we're going to draw a line of best fit. So what a line of best fit does is it has to match the trend in the points. So I'm going to put some little notes down here. Line of best fit. So it has to match trend in points. Match trend in points. Or data. Call that data too. Has to have roughly half the points on each side of the line. Half points on each side of the line. So it's really easy to do with a clear ruler, because then I can count. So half and half, so I had 10, I should have 5 on one side. It doesn't have to be exact. Probably somewhere around there would be a good line of best fit. So there's my line of best fit. I do it all the way back to the y-axis, so then I can figure out my y-intercept really easily. So does it match the trend in the points? Sure, the trend, it tends to go up, so that's the trend. and I've got roughly half the points on each side of the line. I've got it passing through a few points. I can't go, I'll show you some wrong examples. I can't make one like this. I can't make one like that even though it's half the points on the line and half the points on the other side because it doesn't match the trend in the points. I also can't make one that's like this because while it passes the trend, it doesn't have half the points on one side and half the points on the other. So you've got to try and make sure you have both of those things. So match the trend in the points and half the points on each side of the line. So we drew our line of best fit. Is it increasing or decreasing? So you always read a graph from left to right. So from the left, it's increasing as it goes to the right. So it's increasing. And then would you think this data would be continuous or discrete data? So it's been a while since we've talked about this, but continuous data is data where it could be any number in between. So could you be going 0.5 of a kilometer, or could you have a fuel consumption of 2.16? Then the answer is yes, of course you can. It doesn't have to be whole numbers. It can be any number. So this would be continuous data. Continuous data. Because speed and fuel consumption can be any number, any value I'm going to put. Okay, so decimals or fractions. So that's what makes it continuous. Hopefully that helps. Like I said, pause, rewind where you need to. You're going to be working on page 327, number 4, 5, 6, and 8. Okay, and I think the supply teacher is going to give you some extra little things to add to your notes too. Okay, have a good day. Good luck.